Thanks everybody for coming. My name is Akash Sharma. I'm an IoT solutions engineer with ClearBlade. ClearBlade is a company focused on helping its customers build IoT solutions. And this is session 4 in our ClearLab series. That's a series of 30-minute seminars we're putting together to help developers build IoT solutions using our platform. Be aware that this video is being recorded after the seminar had already been completed on August 13th of 2020. During that seminar, I would have asked you to look for the email that would have invited you to the seminar, because in that email, there was a link with the words learn more. And if you clicked on that link, it brought up a page that had some content that we used during the session. Now, if you happen to have the email that invited you to session 4 of the series, please find that email and find that learn more link, click it, leave the page open in a browser tab, and we will use some contents from that page. Now, if you don't have access to that email, then be aware that the contents are probably attached in some form to this video. So as you see me refer to those files and contents during the video, look for the attachments and you'll probably find the equivalent somehow attached to this video. We have a lot to do, so let's jump right into it. Let's talk about the project we've been building over a couple of sessions. We'll go through a guided development, and there are no questions and answers because this is being recorded after the fact. So over the last few sessions, we've been building a system that acquires temperature data and displays it. The system started off by acquiring 1 point of temperature data, and then we expanded it to record an array of temperatures and display them. Now, these temperatures, first of all, came from an endpoint maintained by the National Weather Service. And we said that eventually we wanted to have these temperatures come from some temperature sensor mounted to some asset that was important for our business. And just for the moment, we were pretending like the Weather Service data was those temperatures. Now, the end goal is to have a temperature sensor mounted to an asset that's important for our business, reading temperature readings, feeding them to some analog input of some embedded device, again mounted on that asset, something like a Raspberry Pi, and that embedded device would be running some code that would push that temperature data all the way up to our platform. Last week, we took a big step towards that end goal by learning about MQTT. MQTT is a communications protocol that allows publishers and subscribers to publish and subscribe to topics. We built a stream service that subscribed to a topic where temperature data would be published. And we published the temperature data to that topic manually, essentially bringing up a browser tab and typing values in. And so we pretended like we were the embedded devices publishing the temperature data. And our stream service would catch that data, write it to a collection, and our widget in our portal would display that data. Today, we're going to take another big step towards the end goal, and we're going to have an external MQTT client that's basically a Python program written in Python 3. This program will publish to the same topic that our stream service is subscribing to, but in addition, it will also subscribe to its own topic, one through which we can send it requests. Now, this external program will authenticate on our system. That means essentially it will log in to our system, and it needs to authenticate either as a user or a device. Now, as a user, all it needs to do is present an email address and a password. We already registered a user in our system, and so the Python program can pretend to be that user. But usually we think of a user as being a human being, and so we're going to create a device and have our Python program authenticate as the device. For our purposes, the only difference between a user and a device would be that a user has credentials that are email address and password, whereas a device has credentials that are device name and device key. And in the process of going through this, we will also modify our widget parser. It has a limitation that we need to overcome. So at the end of this session, we will have built a Python program that will be our external MQTT client. We will have modified our widget parser, and our widget in our portal will display temperature data as it comes in. Now look at the screenshot and notice that on the left, you see this temperature data jumping all over the place. In the middle, it looks fairly subdued and sane. It looks stable. And then on the right, it jumps all over the place again. There's a reason for this pattern, and you're going to notice it as we build. So with that said, let's go ahead and jump right into our development. If you have access to the email that invited you to the original session, then and you clicked on the Learn More link, it would bring up this page. And if you don't have access to this page, then be aware that the contents I'm going to mention are probably attached to the video. So I would like you to, first of all, right-click on MQTT client user device.py and make that open, bring that up in a new tab. This is the finished Python file. We'll essentially copy and paste this into a code editor and tweak it. We don't have time to write that whole thing from scratch. Now, if you right-click on the scatterplot widget parser.js and open that in a new tab, that is the modified widget parser. Most of this is the same as what you already have, but there are a few lines which are changed. Now, with that done, I would like you to open yet another new tab, log into platform.clearblade.com. And if you have a login, go ahead and log in. And if you don't, you'll have to register down here. You don't need a registration key, but you need to submit all the other information. Submit, agree to some terms and conditions, then you can log in. And once you log in, you'll see a screen something like this. Now, if you've already built your own temperature monitor system following all the instructions all the way through to the end of session 3, then you are welcome to continue using that system today. But if you have a temperature monitor system that is only partially built, meaning you did not follow all the instructions through to the end of session 3, what I encourage you to do is go into that system, click on the gear icon for that system, and change its name to temperature monitor underscore in progress or something like that. Then you can, in addition, get the completed system for session 3, which is available from the same page. Near the top, you'll see this link for zip file. If you click, that'll download the zip file. Hopefully you know where that went. Now you can go back to your console home and you can add the system. If you don't have any systems, the add system button is down here. If you already have some systems, then the add system button will be off to the right, and you can find it fairly easily. Click add system from file, click the cloud icon and browse to the location of the zip file. You don't have to extract anything, just pick the zip file and let it upload, and there you will have the completed system as it was at the end of session 3. Now, the first thing we'll do is go to our users page, click there. And if you have your own temperature monitor system that you're using, you already have your own user. But if you're going to use this user, then click on the gear icon, go to settings, change password, and type in a password that you will remember and update. And be aware that even though this is a dummy email address, we do recommend that you use a real email address for your users. Now, I said that we're going to create a device, but let's hold off to do that until we start writing our Python code. We'll come back to that. Go to your portals for the moment. Click on Temperature Monitor portal. Do login. And notice that the widget is empty. And that makes sense because the collection that is the data source for this widget has no data in it. And that is on purpose. When we create these zip files, when we export the systems, we don't want them to contain a bunch of unnecessary old data. And we are ready to use this portal at this point. Don't worry about what this says under the gauge widget. This is that endpoint for the National Weather Service endpoint that we don't really care about anymore. We're really focused on the scatter plot widget for this session. Now, I'd like you to go to the Python file, Control-A, Control-C to copy all of it. And at this point, I would like you to paste that into a new file And I encourage you, if you haven't picked your own favorite code editor, to use VS Code, or at least give it a try. If you use a text editor, that's okay too. Go ahead and save the file and save it somewhere where you have access to it for future sessions. And I'm going to save it with the name MQTT client camelcase.py for Python. Now, before we run this or even look at this code, I would like you to go to a terminal. So depending on which operating system you're using, this could be a Mac terminal app, a terminal in Linux, or it could be a Windows prompt if you're using Windows, or maybe a PowerShell prompt. It's up to you. One that you can use to browse to the directory where the Python file is. So use CD and browse to the file where the Python file is. I happen to be already in that directory. And before we do anything with the Python file, I want you to try the following. I want you to type Python, enter. And I want you to notice, when you did that, did these few characters at the beginning say Python 3 point something or 2 point something? If they said 3 point something, then you're going to launch your file using Python 3. You're going to launch your file using Python space and the name of the file. But in my case, this is not Python 3 something, it's Python 2 something. So I'm going to exit, open, close, and I will launch my file using Python 3 space and the name of the file. I do want us to use Python 3 and newer. Let's go ahead and type Python 3. Now, if you have Python 3.6 or newer showing up here, as opposed to Python 3.2, 3, 4, then you're going to be able to run your file using Python 3 space and the name of the file. But if what you're seeing here is below Python 3.6, then there are a couple of statements that you're going to need to comment out. You're going to need to comment out line 86 and line 89. In fact, those don't really matter that much. All they do is print some feedback to the terminal window, and we really want to focus on the widget in our portal. So just be aware, lines 86 and 89, these F strings were introduced with Python 3.6. So if you have a Python 3 point earlier, then you can't use those. Okay, so let's go ahead and exit. And once again, if you, like me, have to use Python 3 to launch the file, there's one more thing you should do. You should go ahead and type in pip3 install ClearBlade. The instructions in our SDK page might have said use pip install ClearBlade to install the ClearBlade Python SDK, but then it would have installed it as a module for Python 2 versus Python 3 if you have both installed, as I do. So let's go ahead and do that. If you've already done it, if you already have it installed, this is not going to hurt anything. Okay, with all that said, let's go back to our Python code and take a look at it. There's a lot going on here. This is not a Python course, so we are really going to focus on this from the point of view of what's important for the task at hand. So let's look at a few lines. Here on line 12, you see we're importing a class called system from essentially the module that we just installed. Now, this will allow us to create a system object. Here's the class, and we're calling it init function, basically. And to create the system object, we need some credentials. We need the system key and the system secret. Now, how do you find those? You can actually look at any browser page which is pointed to a part of the console system components, and you will find the system key as part of the URL. But a better place to go is to go to the home page of the system home, click on the gear icon, scroll all the way to the bottom, and you see system key and system secret right here. So let's copy the system key and overwrite that. And do the same with system secret. Copy, overwrite that. Now with the system key, the system secret, and the URL, which of course is platform.clearblade.com, now we have a system object that essentially points to our actual system. Now we need this code to log into the system, authenticate on the system. And it could do that as the user that we already have registered in our system. I could do that by uncommenting these few lines. But we said we don't want to do that. We wanted to authenticate as a device. So with that said, we cancel here and let me go to the devices page and let's add a device. And the name of the device we're going to give it is device 1, same as here. And you can type in your own device key here and here if you wanted, but we already have a randomized device key. Let's just copy that and paste it here. Keep saving, Control S. Go ahead and click create on the left. Now we've created our device. It is given the authenticated role, the same as the user that we already had. So this device, once logged in, has the same privileges as that user had when it was logged in. So go ahead and hit update roles and let's continue. Let's see what happens next. Once I have the user or device object, which gets created right here, I can then create the MQTT client object using this system messaging init function for the system messaging class. And that function takes the device as a parameter, takes the port number as an optional parameter, and this use TLS as an optional parameter. Now the port number can either be 1883 or 1884. Those are the two ports that our MQTT brokers listen on. 1883 for unencrypted communication and 1884 for encrypted. And I've chosen to use 1884, and for that reason I've also said use TLS equals true. TLS stands for Transport Layer Security. You may know of that as SSL. Essentially, they're the same thing. Now, once this is an MQTT client, we wanted to subscribe to a topic and publish to a topic. Now, let's think about this. Can this MQTT client that's authenticated as a device that has role authenticated, is it allowed to publish to and subscribe to these topics? We don't know yet. Let's go to roles on the left, find the authenticated role that has been assigned to this guy by the time he connects, scroll down to message topics, and aha, we see that authenticated does not have any privileges with these two topics. So let's go ahead and add device/1/+ wildcard. Click away. So now authenticated entities can subscribe to or publish to topics that match this pattern. Make sure to click save and exit, and let's continue. Now, let's think about this. This Python program is going to publish to device 1 temperatures. Who is subscribing to that topic? You remember before in the last session, we created a code service. So go to code, and it's this log temperatures code service. Go there. It was a stream service. I want you to go to the advanced tab and see if there's currently running any instances. Apparently not. No instances currently running. So I want you to go back to the code editor tab, hit save and test, go back to the advanced tab, refresh. Now you see one instance running. That one instance will catch the messages as they get published to that topic. Let's keep going. Here we have a function we create, which is an event handler for the onConnect event. So the event that is essentially the connection of the MQTT client to the broker. When that event occurs, what we're trying to do is make that client, our client, subscribe to this topic, and that will happen. And now we have another event handler for the onMessage event. That is the event that means that a message was published to this subscribed topic. And what we do when that event occurs, meaning when a message gets published, is we take the message, we take its payload, we decode it as a string, and we write the contents to this variable incoming request. Keep that incoming request in mind. Now, once we have these two event handlers, we assign them to the MQTT client objects on connect attribute and on message attribute. Once all that is done, now we can do the actual connection. And now we have an MQTT client connected to our broker. Then let's scroll down here. I have a for loop. Let's keep it very simple. What this for loop does is on every iteration, it generates a random number that varies between some lower limit and some upper limit, and we treat that as our temperature. And we either publish that temperature, that raw temperature value, to our published topic down here, or we take that temperature and write it into a sliding window of right now 10 samples, and essentially creating what we can think of as a sliding window average or a moving average of those 10 points. And then with every iteration, we can write that smoothed or averaged temperature right here, smoothed or averaged temperatures published data, and write that to the topic. So which one would we write? Well, it all depends on what was the value of incoming request. If incoming request that we would have written if we had an incoming message on the subscribe topic, if incoming request happens to be the word smooth, we write the averaged data to the published. And if incoming request was something else, then we write the raw data to the published topic. And down here, we just have some code that allows us to elegantly exit by hitting Control-C. All that done, let's go ahead and look at our portal. And let's look at our terminal. And now let's run our Python code. Python 3 MQTT client.py, hit enter. And now you should see our widget in our portal displaying data as it comes in. And this is exactly what we wanted. Now, while this happens, let me open up a new tab, go to the messages, and let me subscribe to device 1 requests, subscribe, and let me publish to that topic the word smooth. And when we do that, let's see what changes. Now you should see, rather than jumping around all over the place, you'll see this data settle down. See that? And then let me change it back to raw. And it doesn't have to be raw, it just has to be something other than the word smooth. And then you'll see that the data will again start jumping all over the place. Okay. And so we have an external MQTT client in the form of a Python program. It is publishing data to an MQTT topic. It is subscribing to an MQTT topic. It can give us data and it can receive data. And it could very well be sitting right next to a transducer or sensor, receiving, as I said, analog data through an analog input and feeding that all the way up to our widget in our system. And now we really have something close to real asset data being pulled into our system. So with that, I'm going to go ahead and stop my Python program. And I'll mention that at this point, we have a system that we can do quite a lot with, but there is a limitation, and that is what happens if we lose connectivity, internet connection between the embedded device and our platform, our system in the cloud, well, everything could come to a screeching halt on the embedded device. So what we can also do is have a broker that's sitting on the embedded device and have our Python program talk to that broker, and that broker be synced up with our broker in the cloud, such that if there's ever a disconnection between the two brokers, between our edge, as we call it, and our cloud platform, then the edge can keep the embedded device's code running using some rules that are predetermined and make the whole thing a lot more robust. So with that said, I will go ahead and bring this video to a stop, and I encourage you to watch all the other videos if you haven't, and please do join us for future sessions of ClearBlade's ClearLab series. Thank you very much.